Now let's look at selection sort. So the algorithm basically works by repeatedly selecting the smallest or largest element from an unsorted part of a list and then placing it in the correct position. And how it works, the step-by-step process of using the selection sort algorithm. First, you start by dividing the list that you're given into two parts. So you're going to have the sorted part and the unsorted parts. So basically, divide to start with this, yeah, divide to the sorted and unsorted part, the unsorted parts. So once you have, this should be an n. So you divide the list into a sorted part and unsorted part. After doing that, the next thing you're going to do is you're going to find the minimum element in the unsorted part. So find minimum element in unsorted part. After finding the minimum element in the unsorted part, what you're going to do is you're now going to swap that element with the first element of the unsorted part. So basically, swap, so swap it. I just say swap it. That should be enough. Should be a p. So swap it with the first element of the unsorted part. Right. So just say swap it with first element in unsorted part, in unsorted part. So after swapping the element in the, with the unsorted part, you're going to basically move the boundary of the sorted one. So you just move the boundary to the right, and you're going to repeat that process until the entire list is sorted. We just say move boundary to the right, and repeat the process. Now, I know what I've just mentioned here. Let's see how this would look like when you're dealing with an array. So when you already have a list that you're supposed to sort, and let's pick this list that we had here at the beginning, and we're going to try and apply the selection sort on this list. So how this list would look like, the first thing you're going to do, like you've mentioned, is you need to basically divide the list basically to sorted and unsorted parts, right? And in this case, in our list here, what we're going to do is we're going to find the smallest element first, because at first what we have here still seems really unsorted all through. So what we're going to try and do is we're going to find the smallest element, and the smallest element that we're going to find here is going to be, the smallest element is going to be this one that is here, is the smallest element. What we're going to do is we're going to move to the third step, and then we're going to swap it with the first element of the unsorted part. So this entire is going to be the unsorted part. So we're basically going to move this one, then it's going to come here. So once we do that, how this list is going to look like is what we done here. So we're going to have a list that looks like this, and now here we have 1 and 5, and the next element that we have here is 5. So once we do this, we now sort of have a sorted and unsorted part, because 1 is the smallest element. Now this is going to basically represent the sorted part. Then next, this entire next is going to be, this is going to be the unsorted part. Then now what we're going to do is we're going to go to the second step, which is finding the minimum element in the unsorted part. So this is the unsorted part. The minimum element here is 2. Now, since 2 is the minimum element that we have, we're going to also swap it with the first element in the unsorted part. So we're going to swap this 2 and 5. So we swap this 2. We're going to swap those two elements there. Uh, so let me just use a different color. So we're going to swap this 2 with 5. We swap them. Now after doing that swapping, this is going to look like this. Now the next thing it's going to look like is we're going to have our 1 here, of course. And then here we had 5 before, but now it's going to be 2. And then where we have 2, we're going to have 5, like that. And then basically we're going to repeat this process until the list is fully sorted. But as you can see now from the looks of our list, it looks pretty sorted. So the process is basically going to stop here. But if the other, so 1, 2, 4, 5, 8. So if the other we had sort of elements that were smaller on the other on an unsorted part, we would just repeat that process until it's done. So this is going to be this is the first step here. The first step, finding the sorted and unsorted parts. Then we swap the minimum element in the unsorted part. We basically swap it the first element in that unsorted part. Then we just basically after we've done that, we move the boundary to the unsorted to the next step, and we repeat the entire process like this until the list is fully sorted. Now let's see how this looks like in code. And again, we're going to do this implementation in Python, but feel free to do this similar implementation in a language of your choice. So what we're going to do basically, we're going to have a function here, takes in the array that we want to sort as a parameter there. Then we just check the length of our array. So this is going to be important in our iterations. Then now we're going to just basically iterate, and we'll say for I in range, and then that n. Then the next thing we're going to do is we're going to identify the minimum index, that is the element that is the minimum here basically. So we can just say the minimum index. So let's just call it okay. Let's just call it like a minimum index, and then it's going to be at index I. So after getting this minimum index, I'm going to go and do a second iteration. Just say for j in range. Remember, we need to do the second iterations to help us do the comparison between the two elements easily. So for I in range, I plus 1, then n. And then the next step that we're going to do, we're going to follow from here, we're going to basically check in terms of the size of the elements, the adjacent elements. So we're going to just use an if statement, and we're going to check if the array at index j, so if the array at index j is less than, so if the array at index j is less than the array at the minimum index, that is now that again that is our process. So as you can see here, we said we're going to basically find the minimum element in the unsorted part. So we're trying to compare if the array at index, if an element at index j is less than the basically the minimum element, we are going to basically make that the minimum element. So basically what we're going to do here is minimum index is going to be that j. Now, after doing this, or rather outside of this, otherwise here, we're going to go ahead and check the array at index I, and we're going to do the swapping. So we just take the array at index I and the minimum element, that is. So we're going to check the two and swap them. So we're going to swap I with the minimum index. Should be min with the minimum index, and then we're going to also swap minimum index with I. So we're going to swap this with the one at index I. It should be I, not 1, like that. And by doing this, basically we're done. Now the next thing we're going to do is just going to return the sorted array. So we're going to just return the sorted array like this. Now let's go ahead and test this out. I'm going to print the output. So we call our function, which is called selection sort. Then we're going to give it an array, as we're going to give it an unsorted array as its parameter, as an argument. So we can just check the array that we had here. So which is 5, 1, 4, 2, 8. So 5, 1, 4, 2, 8. So we're going to take that, and let's run our code and see. Do Python 3 selection sort. And yeah, so you can see now our array is sorted. We have 1, 2, 4, 5, and 8. And from what you had gotten earlier, it's again the same thing. 1, 2, 4, 5, and 8 is that is the sorted array. And that is basically how selection sort works. So the same way as, or rather, the same thing as when you are looking at the other sorting algorithm, which is bubble sort. In terms of time complexity, both of them are going to have a time complexity of n squared. Let me just write it here, and we can have it in, yeah, let's just have it in red. So the time complexity is going to be O of n squared, uh, of n squared. It's going to be the time complexity, and this is in the worst case. But if it happens to make a fewer swaps, then it can be a small advantage in some special cases. But now, same thing as bubble sort, selection sort also has a time complexity of O of n squared. Thank you for watching this far. In the next video, we're going to look at insertion sort.